Greetings and salutations. This is Frederick John. Today we're going to be taking a look at the Phoenix framework once again. Specifically, we're going to take a look at user authentication and authorization. We're going to be working with Phoenix 1.3 since that's the latest version available. The user authentication process is similar across MVC frameworks. The main component of this process is the cryptographic hash. Hashing can be complicated on a low level, but from a high level, it should be very easy to understand. We're going to say that we'll have a hash function on string A, and that's going to give us the hash of A. And then we'll have a hash function on string B, and that's going to give us the hash of B. And the important thing to understand is that the hash of A is never going to be equal to the hash of B. So when we use this cryptographic hash function, we're going to get a unique string as the output. So we're going to have some type of input, and we're going to have a unique string as the output. To better understand this, we can use a program that's called iHash. And let's take a look at how it works. We can give it some text, and we can use MD5 as our hashing algorithm. Let's say we're going to give it the text BANANA, banana. It will respond to our input by providing an MD5 hash output, and here's that output right here, 72 lowercase b 302, and it keeps on going. We could copy this output, and let's say we give it a different input. Let's say we give it the input of apple. You can see it gives us the hash value. Let's compare it to our hash value of banana. You can see that they're different things. Well, let's give it banana, but we're going to put an extra N in the middle. BANNANA. Banana spelled incorrectly. To compare that to our hash of banana, you'll see that the hashes are completely different. Even though it's one letter off, it produces a completely different hash. The only way that we're going to be able to get our two outputs to match is if we have the exact same input. And as you can see now that we've spelled banana correctly, our MD5 hash is the exact same. That's why we have a check mark here. So this is just a little tool that we can use to check on hashing outputs. Essentially, how it works for creating users or logging users in is you take the string password that the user is going to submit, you create a password hash based on a hashing algorithm of your choice, you save that password hash to the database, log the user in. The next time that they want to log in, they submit their password, and if it matches the password hash that's saved into the database, then you know that you have the correct credentials. So you would look up the user, let's say by email, check their password hash. If their hashes match, then the credentials that they've entered are correct. You could log the user in now. If the passwords do not match, it means that the user submitted a different password than they had originally created the account with. Let's dive into this by creating a new Phoenix application. We could do that with the mix command, mix phoenix.new, and followed by the name of our application. We'll call our application Snappy. Do we want to fetch and install dependencies? Yes. Okay, so the application has been created, and the first thing we'll do is, as the instructions suggest, we'll cd into the directory and create the database. Here's a look at the process that we're going to go through here. The first thing we'll worry about is creating users. In order to do this, the user is going to have to provide a plain text password. We're going to have to hash the password, and then we're going to have to store the hash in the database. Let's get started by taking care of this first block here, creating users. In order to create our user resource, we'll take advantage of Phoenix's generators. Phoenix 1.3 introduces the concept of contexts, which are essentially namespaces for your application to keep everything organized and modular. The way that we create a new resource and context is by using the generator command mix phoenix.gen.html. followed by the name of the context, which we can call accounts. Then followed by the name of our resource, user, and the plural name for that resource. We're going to explicitly tell Phoenix the plural of user is users. And now we can add the attributes for our user resource, such as a username, which is a string, an email attribute, which we want to be unique, and a password hash attribute, which is also a string. We don't need to declare it's a string. It will be a string by default, but I just put it in here for clarity. Running this command will generate the files needed for us to have a user resource. I've seen several other videos where instructors or developers will say there's no longer models in 1.3. Phoenix no longer uses models. And this is just incorrect. It's still an MVC application, model view controller. It still uses models. The model has just moved. There's no longer a web namespace. So now in our lib folder under our snappy, the name of our application, you can see we have an accounts context here. And in this accounts folder, we'll have a user.ex. Well, this is our model. This is our resource. If we open this file up, you'll see the naming convention snappy.accounts.user. So that should tell us exactly where to find the file. Within Snappy, within accounts, and it's user. And you can see here the generator has automatically defined a schema for us, which contains an email, a password hash, and a username. And the generator has also applied the unique constraint to our email. So this is great. We have our model set up with one command. After running the command, it tells us in the terminal that we need to add the resources route to our router and then migrate our database. So in the router, under the root path page controller index, I've added resources, users, user controller. And before I migrate the database, there's one other thing that I'm going to do. In our mix file, I'm going to add an alias at the bottom of the mix file. I'm going to put a comma and add an alias for ecto migrate, so that each time I run ecto migrate, I want Phoenix to also run ecto dump at the same time. This will give us our SQL structured schema automatically, so at any point in time we can see all of the information for our database. After adding that, I'm going to save this file and go back to the terminal and run mix ecto migrate, and this is going to migrate our database. And then as you can see, it dumps the file to user, snappy, priv repo, and structure SQL. So now that we have that, just to test that everything's working, we can do mix Phoenix server, and we can check out our app, which is running on port 4000. And here's the default page that loads up. If we navigate to localhost 4000/users, it'll take us to our index action, which is going to list all of the users. You can see right now that we don't have any. Let's create a new user. It lists our three attributes here: username, email, and password hash. Let's say username Freddy, email Freddy@example.com, and password hash password. You can submit the information and it's going to successfully create our user. So right now we have a way to create users and show users and edit users and delete users. Everything was created for us when we ran the mixgen HTML command. However, we do not have a way to authenticate our users. There is no option for logging in. If you create a new user, it doesn't really mean anything because there's no way to create a password hash. And if you remember on the process, what we're looking to do is hash the user's password and store that hashed password in the database. So in order to make this application a little bit more user friendly and improve the UI, we're going to get rid of this Phoenix framework across the top and get started. We're going to replace that with a nav bar so we can navigate to our different user pages. So To do that, let's go to the Snappy Web templates, the layout template. Let's add a new file there. We could call that _navbar.html.eex because it's an embedded Elixir template. Here we can grab a navbar from the Bootstrap documentation and copy and paste that in. And we can save that. Now to get that to show up in our app, remember Phoenix has hot code reloading. To get that to show up, what we're going to have to do is use this render method. We can get rid of this entire header and we're going to replace that with a call to render navbar HTML, and we're going to pass in con like that. Okay, so after cleaning it up a little bit, we have our navbar at the top with a few different links. What we could do is replace those links with Phoenix links, so that makes it easier to navigate around our application. Our navbar setup, just going to make it black so it's easier to see. Now it's time to get our dependencies that we'll need for password hashing. We can navigate over to GitHub and look at the dependency called Comeonin. I'll include a link in the description. This is a password hashing library for Elixir. It provides a layer of abstraction that gives a high-level overview and a high-level control of the password hashing. It makes it very easy, and it's pretty easy to get started. All you need to do is include the Comeonin dependency in your application dependencies, as well as which algorithm you'd like to use. There are different ones you could choose from. For the purpose of this tutorial, I'll choose the Argon algorithm. We're going to get the Comeonin as well as the Argon to Elixir, and we're going to put those in our deps within our mix file. So we'll add these to our dependency list, save the file. At that point we can stop the server and run mix deps.get. Remember our process in creating users. The user is going to provide a plain text password. We're going to hash the password and we're going to store the hash in the database. Now that we have the dependencies for hashing passwords, we could go ahead and complete this first block here. The first thing that we'll do is create a file for encrypting passwords. We can create the file under lib snappy accounts encryption.ex. I'm going to paste some code in and then go over what that code does. See here we follow the naming convention, the application name, the accounts context, and the encryption is the file name. We alias the Comeonin library, and then we have two functions here. Hash password, in which we'll pass in the password, and the function hash pwsalt, and the password that was passed in. The second function is validate password, where we're going to be passed a password and a hash, and we're going to call the Argon2 module the check pw function, and we're going to pass the password and hash in that. The next thing we'll do is go to the user model within the accounts context, and you can see under the schema here we have several different fields which are mapped to the database fields in Postgres. What we need to do is add some virtual fields. Virtual fields are not persisted to the database. They're just used temporarily. So for example, we'll need a field that's called password. That's going to be a string and virtual. We'll also need another field, password underscore confirmation, which is also a string and a virtual field. What this will allow us to do is use the password that the user gives us, and then in the change set, when we're persisting the user, we can change that password into a hash. It also allows us to check if the user typed the password confirmation in correctly. So let's save this file and then navigate to our user form. You can see here we have a text input username, text input of email. We should change this to an email input. By changing it to email input, this gives us the HTML5 validations. And for the password hash, we should put a password input so that it hides the password while the user is typing. We can also copy this last block and add a password confirmation. and change our password hash to just the password field. And then we can save this file. So what we have here is a form for creating users. We give them a text input for their username, an email input for their email, a password input for the password virtual field, and a password input for the password confirmation. With the password confirmation, Ecto will check and make sure that the passwords are the same. And remember, this is a virtual field, so it's a throwaway field. We don't persist it to the database. We're going to use the password field to collect the user's password, and then within our change set, as we're persisting the data, we're going to swap out the password with the password hash. So we can take a look at that next. That will be in the user model. So in the accounts context, user, we need to make some changes. The first thing we'll do in the user file is declare some required fields and optional fields. We're going to say that the email, username, and password are required. And then in our change set, we're going to cast the attributes, required fields, optional fields. We'll say that both the username and email are required fields, and there's some more validations we want to use before the constraints. You want to use your validations before the constraints. We already have a unique constraint on email. We also want to add in some additional validation, such as validate the format of an email to contain an @ symbol, the length of a password, a minimum of 6, and make sure the validate confirmation of password, Ecto looks for a password underscore confirmation field and make sure that they are the same. So now we have some validations. We have our unique constraint on the email. The last pipeline is going to be encrypt password, which is a function that we're going to write right now. It will be a private function. I'm going to paste it in here and then go over it. So our last pipeline, assuming that everything else has gone through, if everything works, then we're going to encrypt the password. For this function, we're going to pass in the change set, and we're going to get from the change set the password field. Remember, that's the virtual field that the user typed in their password. And essentially what we're going to do is call our encryption module and hash password, giving it the password. This line right here is what hashes our password for us and turns our string into a unique hash. Next, we're going to change the change set password hash with the encrypted password that we just made. So essentially what this is saying is take the password, use the encryption module to hash the password, and then change the password with the password hash. And this is the field that is persisted to the database. Otherwise, just return the change set. So with this function here, we should be able to run through these pipelines, creating a new user, meeting all of our validations, constraints, and getting a hash password. So let's save this and give it a try. So my server is running here. I'm going to open up our application in Firefox Developer, go to the register link. That's going to take us to the new user form. We're going to say username, cooldude17. For a password, I'll use password, and the same thing for the confirmation. And we have an error here. Function encryption hash password is undefined, and the encryption module is not available. Called with one argument, password. Okay, so let's see where this error is coming from. Phoenix is telling me that it doesn't know where this encryption hash password module is. This occurred in our user module, line 38. Let's go back to line 38. Along with aliasing the user, I also need to alias the encryption module that we created. So if I save this and go back, we should be able to create a new user now. User created successfully. And you can see here we have the username, email, and it's given us the password hash right here. I wonder what would happen if we tried to create a new user, but we passed in some information that didn't meet the validations. Let's create another username. Cheergirl19. Her email can be cheerchick19@hotmail.com. And for the password, we'll pass in password. Password confirmation, we'll pass in just pass. And submit. Okay, something went wrong. Check the errors below. It gives us an error, and then it also tells us exactly what our error is. Does not match the confirmation. So let's pass in a password that does match. but an invalid email. We have our HTML5 validation here telling us it's not going to submit the form because it knows that it needs an email. What if we pass in no username? Then we get back an error, can't be blank. So let's go through and create this user. And let's see what happens if we try to create a new user with the same email. It'll tell us that this email has already been taken. So now everything is working for registering users with passwords. Now if we are a user, let's try to figure out how we can log into this application. Let's go back to our process so we have an overview of what we're doing. We already know how to create users. Next we're going to be logging them in. So we'll need the user to provide us a plain text password. We'll need to hash that password that's provided to us, and then we're going to have to compare this hash with the hash that we have in the database for that user when they created their account. And if we have a match, we're going to log our user in by setting the user ID in the session. We already know how to do these first two things. We do that when we create a new user. Now, the last two are what we're going to need to learn how to do: compare the hash and set the user ID in the session. In order to do this, we're going to need an authentication module. We made the file for encrypting passwords and also validating passwords. That's our encryption module. What we'll need to create is an authentication module where we can log users in, and then some type of session controller where we can interface between our authentication module and the application's user interface. In order to set up our authentication, we're going to be working in the Snappy directory in the accounts context, create a new file called auth.ex. What we're going to do is we're going to decouple the user authentication from the actual password encryptions. Next, let's take a look at the auth file. I'll do the same thing, paste some coded, and then go over it. So this is the snappy.accounts.auth. As you can see, we're going to alias two different modules on the top: the encryption module that we just created, and then the user module, which was created for us earlier when we ran the generator. And this module is going to have two functions in it: login and authenticate. The login function is going to take in params and the repository. It's going to get the user by the email and then downcase the email that the user passes in. So that way, if the user passes in an email that has capital and lowercase letters, it will be downcased and then compared to the email in the database. Now we're going to use a case statement in which we authenticate. This is the function that we declare here. The user using the password of the params that the user passed in. If it's true, then we're going to return the user. If anything else comes back, we're going to return an error. Here's our private function, authenticate, which means it can only be called from within this module. It is called by login here. Another case statement: if the user is nil, we're going to return false. Otherwise, we're going to use the encryption module that we created and the validate password function. We're going to pass in the password and the user.password hash. This is the value that is coming from the database, the saved user password hash, and we're calling encryption.validate on the password. So what that's going to do is it's going to validate the password by using the checkPW function of the Argon2 module, in which case it's going to hash the password that's given and compare that to the database value of hash password. If they're the same, that means we have a match and it's our user logging in. And if they're different, it means for some reason the password email combination is incorrect. And now that we have this, what we'll need to log users in and out is some type of controller. So under Snappy Web Controllers, we'll create a new controller called Session Controller. We'll make sure to follow the naming conventions, snappyweb.sessionController. It's very important that we have this macro at the top of the file, use Snappy Web Controller. This is where the controller gets all of its functionality from Phoenix, similar to how Rails would do inheritance from a parent controller like application controller. In Phoenix, we're using Snappy Web Controller, and that's going to bring in all the functionality that we're going to need. Now, I have some aliases here at the top for when we do our authentication, but for right now, the first function that we'll need is a function called new. It's just going to take the con and render new HTML. And remember, this new HTML refers to a session view and a session template. So we'll also need to go to our views and create a new session view, and we'll need to create a session folder under templates, and in the session folder we'll need to create a file called new.html.eex. Our session view doesn't need anything in particular, it just needs to exist and use the use Snappy Web view. And in the new.html, this is what we're referring to in our controller when we say render con new. Phoenix is going to look for the session template folder and a file called new HTML. This is going to be our login page, where we're going to take an email from a user and a password, match their email, and then compare a password hash that we're going to generate to the password hash that's in the database. I'm going to paste some code in and then go over it. So this is a bootstrap row. Div class, take up 6 columns, but offset the columns by 3. And then I'm just going to use a card for some styling. It's going to say login, and it's going to have a form, and the form is going to the session path create for the action we didn't create yet. Remember, we just have a new action, and our new action is going to display this form. And this form is going to go to the session's create action, which is actually going to use the authentication module to authenticate our user. So a form group for the email here, and I'm using font awesome and just putting a little icon next to it. That's not specific to this application, that's just some styling that I did to make it look nicer. A form group for password, and a submit button. So when you look at it, it might look like a lot of code, but there's not much going on here. That's the end of the form. At the bottom, I'll put a little item in the footer that will say if you don't have an account yet, you need to register for one, and you could register for one if you click here. And that will go to the user path new, which is what we use to create new users. We need some routes in our router, so I added 3 routes for sessions. Get login to the new action, post login to the create action, and then delete log out. And that's the delete action. So this is what users are going to use to navigate around our application, and it's all pertaining to the session controller, which is logging in and logging out users. I added some styling to the application to make it look a little nicer. I just used the boot swatch theme that's called Lux because it already had a black nav bar, so I just grabbed that CDN and put it in, and I grabbed the font awesome CDN. So now we have some icons here for our login, and we can input our email and our password and log in. And if you don't have an account yet, you could register here. Takes you to the new user page. If we go back, we have our listing users here. So all users, our account brand homepage, we have a login button, takes us to session controller new, and then a register button, which takes us to create the new user. So for our login, our users are going to provide an email, they're going to provide a password. So the next thing we'll do is create the action for creating a session, which is going to be the session controller create action. So let's add that now. Okay, and what this function does is takes in the con, of course, and then it does take in the session params, because there's going to be parameters that are provided by the user, namely the email and password. We're going to call those session params. We're going to use a case statement, and this is why we have our alias here for auth and user. We're going to use auth module login and pass the session params and the repo. Now if we go back to our accounts auth, here's our auth module and our login function here. So we're going to be calling that from this session controller. So we're going to call login and then give it the params and the repo. And what auth is going to do is take those params and take that repo, and it's going to get the user by email and authenticate the user based on the password. And remember, what is authenticate? That is this private function here, which is going to use our encryption module to validate the password. Remember, our encryption module is what actually does the hashing and what actually does the validation. So it's a case statement. What are you going to get back? Either OK and then the user, or an error. So if the case is the error, then what we're going to do is we're just going to put a flash in that said there was an error, and we're going to re-render the new HTML. Remember, when they first came to the login page, they're on the new HTML. So we're going to just re-render that login page to them and notify them through the flash that there's been an error, either an incorrect email or incorrect password. In the case that we do have a user, we're going to put in the session a current user object that's going to be the user ID. We'll notify the user through a flash message that they've been logged in, and we'll redirect them to some page. For now, we can redirect to the root of the application. So let's save this and see that we don't need user here. There we go. So we'll save this file and we'll log in a user. And let's see. The email was example@aol.com and the password was password. Okay. Maybe that wasn't it. Oh, cool dude 17@aol.com. And the example, or the password was password. Okay, we're successfully logged in. Great. So if we put the incorrect information, it doesn't log us in like we saw. If we put the correct information, it logs us in. But if you look at the application's user interface, you'll see that there's nothing besides the flash message that lets us know that we're logged in. We still see the login button, we still see the register button, and if we refresh or navigate away from the page, the flash message will go away. So how are we going to know, if we're a user, that we're actually logged in? How do we know that our user ID is persisted to the session? In order to know if a user is logged in, we'll add some helper functions. Because they have to do with authentication, we'll put them in the auth module. We'll create two functions, the first of which is current user. It's going to use plug con get session and get the current user. And remember, in our session controller create action, when we created the session, we put session current user user ID. So we're going to use that now and get the ID, and if it has an ID, we're going to get the user from the database and we're going to use that ID. And we're also going to have a logged in function, which is essentially going to take the con, and if there is a current user, we're going to assign it. So in order to have these functions work in the view, we're going to need to add something to the Snappy Web module. In the view function, we're going to have to add the two helpers that we created. So it'll be snappy.accounts.auth, and we're going to import only and give it a list of functions current user, which has an arity of 1, and logged in, which has an arity of 1. Okay, so that should work. Let's save this file. Let's navigate over to our nav bar. I've made some changes here. You can see I've added an if logged in, and then we're going to use the current user username with a button to log out. Otherwise, we're going to display the login and register buttons. So if we can save this, yes, so we automatically have our username here and a logout button. This logout button is not going to work because we haven't actually added the function for deleting the session. So we could do that right now. Within our session controller, we can add a delete function, and what this is going to do is delete the session current user, redirect the user to the root of the application, and put a flash up that says you've been logged out. Okay, so with that saved, we now should be able to log out, and this gives us the login register buttons. It gives us a flash message of logged out. We can see all users, register a new user, log into the application. We could log in, and it's going to display our username here. So now we have successfully created an authentication system using the Comeonin library and the Argon 2 encryption for password hashing. There is one last thing that we have to do. There is a problem, and I'm going to show an example of what could possibly happen. I'm going to open up an application that's called Postico. It's for Postgres. I use it for development occasionally. So if we go to the Snappy Dev database, I can see that we have two tables, a users table and a schema migrations table. If we go into the users table, it'll give us information about our users. What I want to do is log out of CoolDude17, and I want to register a user. Let's say the username is Agent Lemon, and the email superfun@aol.com. So you have to account for when you're taking information from users, they may be giving you information that has spaces or capital letters, possibly different symbols. When a user now wants to log in, if they have the correct email and the correct password, it's not going to log them in, because if we look in the database, username Agent Lemon, the email has both capital letters and lowercase letters. So we can't allow users to register a username with capital letters and lowercase letters. This can be taken care of on the user interface level, certainly, but it really should be something that is taken care of on the back end, because you never want to have data going into your database and have it be in the not in the correct form. So we need to make sure that before an email is saved to the database, it's all lowercase. No matter what the user gives us, it's all lowercase that's saved to the database. So we think that, where might that take place? Where's a good place to put that? Well, if we go into our accounts context and we go into our user model, before we save it to the database, we're going to need to downcase the email. So if it passes the unique constraint, right before we encrypt the password, we can add another pipeline, something that says downcase email. And just like we did for encrypt password, we can add another function for downcasing the email. And what this function is going to do is it's going to update the change set with the email, but in all lowercase characters. And now, if we go back to register a new user, and the username is superbad@aol.com, it creates our user successfully. But if we take a look at the database, the email is in the correct form that we need it to be in. So this is it for Phoenix Authentication. I hope that you guys got a lot out of this video. If you like the video, please give it a thumbs up, subscribe for more content, and if you have any questions, feel free to post them below. Until next time.